afternoon. I'm Sidney Porter. I'm conducting a video interview on behalf of the Health Physics Society History Committee. It's Wednesday, the 13th of June. We're here at the Cleveland annual meeting of the Society, and I'm very pleased to interview one of the fine professionals that the Society has, and that's Ken Kase. Ken has been president of the Academy and has been associated for how many years now in the Society?
The Society, I think I joined in 1963.
So that's many, many years. Do you want to tell us about your early days and what brought you into this profession?
Sure, Sid. It was 1961. I graduated from Georgia Tech, actually, with a bachelor's degree in physics. That was before Georgia Tech had a health physics program. I knew nothing about health physics at the time. I was fortunate enough to get a position with Lockheed Missiles and Space Division in Sunnyvale, California, and was assigned to a satellite program which was designed to launch a nuclear power reactor into orbit.
ANP program?
Yes. No, the ANP program, I actually was involved in that when I was doing a cooperative education program at Georgia Tech, and I was working with General Electric in Cincinnati. But this was called the SNAP program. And I was given an opportunity to choose what part of the program I wanted to be involved with, and for some reason that's kind of unknown to me, except that I always had a leaning toward issues of biological nature in addition to physics, and so I chose to participate in the part of the program that was evaluating the environmental impacts of a launch failure, which would put the reactor into the Pacific Ocean somewhere near Los Angeles. And as I was working on that, I became more aware of the whole issue of radiation safety. And there was a health physicist at Lockheed at the time whose first name is Artie and whose last name I can't remember for the life of me. I've been trying for days, that I came in contact with. And so he kind of introduced me to the fact that there was a profession of health
Shaw,
physics.
was it?
Not Shaw, no. Sometime during that year, I was reading a publication, and there was an ad in there for the Atomic Energy Commission Health Physics Fellowship Program. And I had been enrolled at the same time I was working for Lockheed in a master's degree program in physics at UC Berkeley. And I saw this ad for this fellowship and decided, well, maybe that's something that I'd like to do. If I got the fellowship, I could quit my job, go back to school full-time, finish my master's degree, and get on with things instead of doing this part-time study business. And so I applied, and I was given a health physics fellowship. And fortunately, there was a program at UC Berkeley at the time in conjunction with the Lawrence Berkeley Laboratory. And so I enrolled in that program and finished my master's degree at UC Berkeley in 1963. So that's kind of what got me into health physics.
Was Wade Patterson?
Wade Patterson was there, Roger Wallace was there, Chuck Sondhaus was there. Those were the three primary faculty people in the program that was related to the AEC fellowship. It was kind of a general program in radiation physics, radiation biology, and we were able to take a lot of courses. I took nuclear engineering, I took physiology, I took radiation biology, I took a radiation physics course, nuclear engineering course. It was a broad educational program, and then of course we spent the summer at LBL doing a project as part of the master's program. So I would say that the people that really influenced my early life in health physics were certainly Roger Wallace and Chuck Sondhaus and Wade Patterson at the Berkeley lab.
What was your next job?
Well, that was what I was coming to. I finished that in 1963, and it was very interesting. Part of that program was that part of the benefit was that you got to go to the health physics meeting that particular year, and the AEC paid for it. The health physics meeting in '63 happened to be in New York City, so it was a fairly long trip from California, and we had to fly at the cheapest airfare, which at that time was still a 4-engine propeller-driven Lockheed Constellation. So it was a 13-hour overnight flight to New York, and we got this fantastic per diem of $10 a day to live on in New York at the time. So that was my first experience with the Health Physics Society. I got to the 1963 meeting, and it kind of captured me. I knew then that this was the field I really wanted to be in. But I always had kind of an understanding, and I think I got this from one of my uncles, who was an engineer, and from my observation, basically he was not a bad engineer, but he got himself trapped into a particular slot in the engineering profession, and it removed a lot of options from what he could do, and he was kind of in a position where he had to go where the company told him to go. Mm-hmm. And I didn't want to get into that kind of position. So I had this philosophy of keeping options open, and I didn't want to slot myself anywhere too soon in my career. So I had an offer from the Atomic Energy Commission and to come back to Washington and to
Bethesda in those days.
The AEC headquarters. And decided not to do that. I had another offer from Lawrence Radiation Lab at the time, Lawrence Radiation Lab in Livermore, to go there, and that's where I chose to go. And that was probably one of the best decisions I ever made in my life. Because
why is that?
At the time, the Livermore lab had almost every kind of problem you wanted to think about having to deal with in health physics. I mean, there was radiochemistry there were actinides and transuranic chemistry, there was problems with accelerators. They had a number of accelerators on site. They had a proton cyclotron, they had an electron linear accelerator, they had a neutron generator. So there were accelerator issues, there were radiochemistry issues, there was a lot of radioactive material handling problems, plutonium, tritium, you name it. There was everything there.
What interested you the most?
Well, I guess when I got there, I didn't have any particular area that I was putting myself into. I wasn't a chemist. My education was more in physics and biology than it was in chemistry. So I kind of opted to go into the accelerator end of things, and so I was given the assignment of being the health physicist for the accelerators at Livermore at the time I was there in the radiation safety section, and that was a great time. Ron Catherine had arrived the year before I got there. Dale Denham had arrived a little bit before I got there, and shortly after I was there, Dick Griffith came on board, and then after him, Dave Myers, Tony Greenhouse. And that was a fantastic group of young health physicists, all of us kind of just getting into the field with this fantastic opportunity of dealing with almost any kind of health physics problem you could think of. And so it was a real education in practical health physics at Livermore at the time. And just because I was responsible for the accelerator radiation safety program didn't mean I was limited to understanding that part of the program. And so I got involved in a lot of the other parts of the program as well. And the way Livermore was organized at the time was that all the safety disciplines were in a single department. So we had a lot of interchange with industrial hygienists, industrial safety people, fire safety people, explosive safeties, and all that. And so we got broad exposure to those safety issues as well, and a lot of opportunity to go to training classes in industrial hygiene, in fire safety, and it was a great time. So I was at Livermore from '63 to '69, and I had a number of different experiences there that helped develop me in health physics and get me involved, and certainly certainly in terms of becoming active in the organization, becoming certified.
You passed your boards while you were there?
Yeah, in 60, I think I took the board exam in 68, right? And let's see, there was one other, well, there was, and starting to write up research work or studies or whatever we did for publication. That kind of all got me started at Livermore, and the biggest influence in that part of my career was Ron Catherine, because he's always been an academic type oriented person, and so one of the first things he did was start pushing people to write up their work and send it in for publication, and so that was a big influence on what followed in my career as well.
Now, what kind of you were doing? Were you doing dosimetry then?
So, yeah, we were doing some dosimetry, a lot of measurements. I was involved in some dosimetry work with the reactor. We had a reactor at Livermore at the time as well, so we did some dosimetry. Actually, I did some in-core dose measurements in the reactor. I did some studies with pencil dosimeters because they were being used. We wanted to use them to measure the dose in the above ground instrumentation shacks for detonations in Nevada, the underground detonations in Nevada. And so we needed to know what their response would be to a very intense pulse of photons. And so we also had a pulsed X-ray machine at Livermore. It was one of these machines where they charge up a big capacitor bank and then dump it, and you get a very short pulse of fairly high intensity. And so what I did was I set up an experiment where I put these dosimeters at different distances from the X-ray target to get a range of dose rates, or doses, total doses, in this instantaneous pulse, and then compared the results of that to the theoretical calculation of using the recombination stuff that was published by John Bogue in the first Edix, Resch, and Toshland series, and proved that these pencil dosimeters were good enough to use. They were pretty much, didn't get much recombination until you got above something in the neighborhood of 10 to the 6th or 10 to the 7th R per second. And so,
how about neutron response?
Well, we studied some neutron response in those dosimeters too, and they don't really respond much to neutrons, so we didn't have a problem with that. So that was one of the early experiments I did there. I also designed shield. Yeah, right. I also had to do a shielding design for a new linear accelerator that they were going to install there, and part of the issue there was looking at the radioactive gas production that might occur.
O15.
Yeah, and N13 and oxygen 15. And that, I didn't do any measurements. I just did kind of a theoretical analysis. That was the first article I published in Health Physics. I forget, I think it was 67 or something like that. So that was kind of the start.
And then what did you do next?
Well, at Livermore, I then got assigned to direct the off-site safety efforts for a couple of the nuclear detonations that were done outside of the Nevada test site. One was the gas buggy program for gas stimulation in northern New Mexico. I was in that activity for a couple of years.
And were you doing environmental monitoring?
Well, I was responsible for all the safety for the Livermore people at these sites. So we did environmental monitoring, and we did all fire safety, explosive safety, all that at these sites. So that got me into a little bit different area of health physics. And then when I came back to the radiation safety section in 1967, I was actually promoted to head the radiation safety section. Bryce Rich had been the section leader before that, and he was moved to another level of management, and I took over the radiation safety section. So the next person on my list in terms of influences in my career would have been Bryce, because I worked under him for a couple of years at Livermore. And then I moved on from Livermore. I left Livermore in '69.
And you did what?
Went to Stanford Linear Accelerator Center. That was, you know, my whole career has been unplanned, basically. I look around and see what's interesting, you know, and I kind of let people know what I'm interested in, and then from time to time people will come to me and say, you want to do this? And if it looks the right thing to do at the time, I'll do it. And in 1969, there were some things happening at Livermore I didn't particularly like anymore. I mean, there was a lot of effort to increase security. It was, you know, it was the Vietnam War time. There were a lot of demonstrations and stuff, and so security was increasing at the site. The plowshare program was dying. The funding was disappearing, and from my own personal perspective, I thought the only thing I could really support from a nuclear explosive thing was if it could be used in some peaceful fashions, and the plowshare program was it, and it was kind of going away. So I was thinking about going somewhere else at the time, and I was approached by one of the staff people at the Stanford Linear Accelerator Center at a health physics chapter meeting one night, and he said, we've got a job opening here, are you interested in looking at it? And I said, sure, I'll come over. And so I interviewed over there, and one of the attractions there was that there was a relationship between Stanford Linear Accelerator and Stanford University, because Stanford University was the contractor for operating the accelerator for the AEC at the time. And one of the benefits was that employees of the Accelerator Center could register at Stanford in their graduate program, and the Atomic Energy Commission would pay 90% of the tuition.
That's nice.
And so that attracted me. So I went there, registered, and started work on my PhD while I was working at the Accelerator Center. And that, of course, was completely accelerator health physics. And that was an interesting place because not only did we do the operational health physics for the accelerator, but we also were able to do research associated with our work at the accelerator. And so that gave me the opportunity to do some more research, get some more publications.
What did you do your research in?
Well, when I was at the accelerator, a lot of it was dosimetry. I made a collaboration with Steve Doman, who was at the National Bureau of Standards at the time. I don't know how many people know Steve Doman, but he's an interesting guy. I'm not going to go into his details here, but he designed calorimeters, and he had designed a graphite calorimeter that was fairly small and portable, so he could move it around. So I got him to bring the graphite calorimeter out to SLAC. And we set it up in an electron beam, and we made measurements, the calorimeter and a transmission ionization chamber of the energy distribution in a high energy electron beam. And we did some other measurements of that type, compared it with transport calculations, compared it with theoretical responses of ionization chambers and that kind of.
Now, how short was the pulse? Very short pulses?
At that time, the pulses were about microsecond type length pulses.
And how high were the energies?
The energies were
above 7.5 MeV?
Oh yeah, they were up at 10 to 20 GeV.
Oh wow!
Yeah,
okay, so
that was the energy that the primary electron beam was running at. Yeah. And that's what we used for the measurements. And while I was there, I worked most closely with Ralph Nelson. He's also a health physicist. He hasn't become very prominent in the Health Physics Society, but his career has been mostly in developing Monte Carlo codes, and many people have probably used the code EGS4, which he developed at SLAC. And So he and I worked together closely at SLAC, and we were actually doing our PhDs together at the same time, and we taught a course as part of our PhD program for academic credit in radiation physics at Stanford University, and that ended up being a little book that we published in the late 70s called Concepts of Radiation Dosimetry that Pergamon Press published for us. And that then led to a change in my career, because when I finished my PhD program, I had to leave SLAC to do my dissertation because I wasn't able to work out a research project that would fit in with the SLAC program. So I left SLAC and finished my dissertation at Stanford, and then moved into medical physics.
And what made you make that big career? That's a big change in careers.
Yeah, well, I was kind of interested at the time in changing an orientation to an area where I might be able to be of more direct service to people. And I'd found out about what medical physicists do, and I thought that might be an interesting thing to explore.
Had you been associated with the hospital before this?
No. Not except in my research. I mean, my dissertation was in the radiation biology section of the radiology department at the medical school at Stanford. That's where I did my research. So I got involved in some hospital stuff in the couple of years I was doing my research. So I went on from there. Again, very fortunate. I was offered a position at Harvard Medical School.
You're jumping a little fast. Tell me about what your thesis was.
Well, that's another story. I didn't know if you wanted to take that much time, but
well, just briefly.
But yeah, I had planned to do a thesis on again on radiation dosimetry and radiation biology, and the program I was aiming for was a pi meson program that the physics department at Stanford and the medical school at Stanford were involved in developing a negative pi meson therapy unit, which people thought at the time would be one of the big advances in cancer therapy.
Right, high LET.
Yeah, right. And so I was orienting my dissertation project to doing the dosimetry and some radiation biology studies on that pi meson beam. Turned out when I was ready to do my research, the machine wasn't ready to use, and so I talked to my advisor, and he was interested in some other things. And so he kind of directed me into doing some research on the cellular effects of high temperature, because at the same time there was a lot of interest developing in hyperthermia as a cancer therapy agent. High temperatures kill cells, so if we can heat cells to the right temperature, we can kill them. And if we can get some differentiation between normal cells and tumor cells, we might get some therapeutic advantage there. So my dissertation actually was way off of health physics, radiation physics, anything else. It was in hyperthermia, and it was in the effects of high temperature on cells. And I used two cell lines. Well, I used a single cell line, one which was a normal human fibroblast cell, and then the second cell line I had was the same human fibroblast that had been transformed by a virus into what appeared to be a malignant cell. So I had these two cell lines from the same origin, one which behaved as a normal cell, one which behaved as a malignant cell. And so I tested the two cell lines at various temperature regimes to see if there was any differentiation in their response to.
Was there?
Under certain conditions there was, and under other conditions there wasn't. And so
the complicated answer.
Right. My conclusion was that under what most mimicked the environment of a cell in an organism, there probably would be no difference in their response to temperature. That was my dissertation research. So that had really nothing to do with anything I did before, and it had very little to do with anything I did after. Although I did get involved a little bit in trying to do some clinical applications of hyperthermia when I was in medical physics, but it never really was very effective, and so we never did much with it. Yeah.
And so you say you went to Harvard after this?
Yeah.
Now, what led you to go to Harvard?
Well, mostly they offered me a faculty position.
And what year was that?
This was in 1975. So I moved my family from the West Coast to the East Coast. They didn't care for it too much. I had 2 daughters. One was 9, one was 12.
Ooh, I bet they didn't.
And I had kind of promised them we wouldn't move before they had finished high school, but I went back on that promise, and turns out it worked out fine. I mean, they both really enjoyed New England once they got into it, and they both did well in school, and everything's great. So the move worked out for all of us, and it certainly was a good career move for me, but it got me involved in another aspect of the whole radiation science business. But I was able to apply my health physics experience in the medical physics area, because most of what I did was the measurement of the radiation fields associated with the linear accelerators that were used to treat patients, characterizations of the beams, quality control, dosimetry requirements, and that sort of stuff. So that's what I was doing in medical physics at the time I was there, but it got me involved then, of course, in the American Association of Physicists in Medicine, so another organization professionally. And so for about 17 years, I was involved in that aspect of things, both at Harvard Medical School, and then I moved to University of Massachusetts Medical School in 1985. And I was there until 1992 when I came back to the Stanford Linear Accelerator Center.
So you took your ABRs earlier?
I took my ABRs in 1979, I believe. I think it was about then.
Now, have you re-specialized since then?
No, no.
And so, when did you become actively involved with the Health Physics Society in this?
Well, I got involved mostly because of Wade Patterson. I got first involved in the American Board of Health Physics once I got my certification. I was appointed to the panel of examiners in the early 70s. Mm-hmm. And I've lost track of how long I served on any of these things, but I was on the panel of examiners for a few years in the early 70s, and then I went off, and then I came back on the panel of examiners again, a second term, in the later 70s. And then I got elected to the American Board of Health Physics. Actually, I was the AAPM designated person on the Board of Health Physics, because at that time there was a slot on the American Board of Health Physics assigned to the AAPM, and so the AAPM nominated me to the board. So I got on the Board of Health Physics, and that was in the early 80s. I was on the board, and then the year I rotated off the Board of Health Physics was the year the Academy was formed, and I served the first year on the executive committee of the Academy. The way the Academy started up, there were a number of executive committee positions, and they were, I think, 3, and one was assigned a 3-year term, a 2-year term, and a 1-year term, so that we could have a site. And I got the 1-year term, so I was on the organizing executive committee for a year. I did serve on the program committee and the research needs committee for the Health Physics Society, and I was on the board of directors in the late 80s for a 3-year term.
Now you've been very active in AAPM also.
Yeah, yeah.
And haven't you served on committees there? Is that right?
Yeah, well, right, and in fact I was more active in the AAPM during the 70s and 80s than I was on the Health Physics Society anyway. I was on a couple of committees for the AAPM, Continuing Education Committee, Finance Committee. I was elected treasurer of the AAPM in 1986, I believe. I served 2 3-year terms as treasurer for the AAPM, so that was 6 years there. So I was on the AAPM board of directors for I think, those 6 years plus 2 years before that. So it was about 8 years on the AAPM Board of Directors in that time period, yeah. And then I've been associate editor for the Health Physics Journal. I've been associate editor for the for medical physics, for radiation research. Those 3 journals I've done editorial work for.
And you enjoy doing that, don't you?
I love it. You know, it's a lot of it's a lot of fun for me, and it's good experience because it gives you always a broad brush of what is important in these areas, and brings you into contact with people that are doing a lot of work that is not directly related with the work I'm doing, and so again, it's this idea of not putting yourself into a box, but keeping your options open, understanding a lot about things, whether you're working on it directly or not working on it directly. And that's another reason I've been very interested in being active in the National Council on Radiation Protection and Measurements.
Tell me about
which is another person that's influenced my career, is Charlie Meinhold, because I talked with him sometime in my early career in health physics and got to understand what NCRP and ICRP were all about. And sometime in the early 1980s, he asked me if I would be interested in being on a committee of the NCRP. And I said, sure, I would do that. And so I was appointed to the Committee on Operational Radiation Safety in 1982, I believe. And I'm still on that committee, so it's been almost 20 years, which seems a little long for me. I took over as chairman of the committee in 1991, so that's been 10 years, and that's been part of my activity with NCRP. I've also been on their board of directors, chaired their nominating committee, and done a few other things within the NCRP. But again, it's one of these ways of being connected with people over the whole spectrum of radiation safety, and getting being able to interact with them, talk with them, find out what's going on, what's important here, what's important there, and understand what impacts, not only recommendations and regulations, but the practical application of these things in the field and practice of health physics.
Now, do you serve on other committees of the NCRP besides the operational?
Right now, I'm also a member of Scientific Committee 1, which is the basic radiobiology, epidemiology committee of the NCRP as well. Yeah.
And who are the people that, besides Charlie Meinhold, that most influence you? Because the NCRP has a wealth of wonderful.
Oh yeah. Well, of course, the people on the committee I chair are big impacts because they bring all this information in, and a lot of it I have no contact with outside the committee work. And the people that have been on the committee in the past, Bill Hendy, Ralph Thomas, Bob Kase, Tom Murphy. And people that are on the committee now, Ken Miller, Susan Langhorst, John Poston, Dave Myers, and I'm not going to name all of them, but I hope those that I don't name don't think I don't value them. but yeah, it's good interaction. And on Committee 1, well, Jim Adelstein is the chairman of Committee 1. He's also the vice president of the NCRP. Jim and I have known each other since I got to Boston in 1975, because when I got to Boston in 1975, Jim was the chairman of the Radiation Safety Committee for the Harvard Medical School. And I was appointed to the Radiation Safety Committee almost the day I stepped into town. And so Jim and I worked together on that committee from 1975 on. And so I've known him for a long time, and so he's been one of the people that I've learned a lot from his nuclear medicine area. Roy Shore for epidemiology, Bruce Becker, famous health physicist.
Absolutely.
Eric Hall, another one. He's been on that
I have
committee.
the greatest respect for Eric Hall.
Yeah.
Wow.
So to be able to sit down at the same table with these people, and kind of discuss radiation protection issues, has been a real benefit to me in my career, and I hope I've also been able to contribute something besides just soaking in all this information and enjoying it all along.
What do you see yourself doing in the next 5 or 10 years professionally?
Well, in the next couple months professionally, I'm going to retire, in quotes, from the position I'm in right now. As I mentioned earlier, I went back to Stanford Linear Accelerator in 1992. It was another unplanned event. I was sitting in my office one day in the spring of 1991, and I got this phone call from my former colleague at Stanford, Ralph Nelson, who said, gee, the head of the radiation physics department is retiring, and I was wondering if you'd be interested in his job. And I had not any plans at that point in time to move back to California, but I said, well, let me think about it. So I thought about it, my wife thought about it. We always enjoyed living in California when we were there before. We knew a lot of people out there still. Figured, why not? I mean, we go to a place we like to live. We got a lot of people that we know and are friendly with out there, and we want to probably at some point in time get away from New England winters before we get too old. So, so I did. I took the job and went back to head the radiation physics department. And 3 years later, was asked to assume responsibility for the Environment, Safety, and Health Division, which was the whole Environment, Safety, and Health program for the accelerator. So that's what I've been doing for the last 6.5 years. And I think now it's time for someone else to take that over. So I'll be stepping out of that job and plan to reduce my work time to about half time.
What are you going to do with the other
2 to 3 days a week.
time?
With the other half of my time, well, like I was telling somebody today, I could probably, at least for the first year, fill it up with just catching up on all the reading I've been putting off for all these years. The pleasure reading, I read all this other stuff, but the pleasure reading is something that suffered. But I'll probably do more than reading. I like to get outside. California is a wonderful place to be an outdoors person, and I can get into the foothills. Between the San Francisco Bay and the Pacific Ocean, half hour from my house, and just hike a new trail every day for probably almost a year without duplicating anything. And I like to do some traveling. I've got 2 daughters. One of them is living with her husband, and two of my granddaughters in the Seattle area, and the other one is living with her husband and 2 other granddaughters in Minneapolis. So I like to visit them from time to time. And I'll probably continue to do volunteer work for NCRP, Health Physics Society, AAPM when I can, things like that, and some other things in the community. Probably. I mean, I've done some work with Habitat for Humanity, and getting out and doing some physical labor once in a while and helping build a house is fun to do. So I'll probably do things of that nature.
Well, in the time remaining, do you have any special advice for young people coming into the health physics and medical physics fields? The fields have changed so radically since you started, and then you've seen a vast change. What do you see happening to the 2 fields? From a numbers point of view, I see that the AAPM is expanding more rapidly than the Health Physics Society is right now. What's your prognosis for the next 10 or 20 years?
Well, I think there's always ups and downs. A few years ago, the AAPM was wondering whether or not there were going to be jobs for medical physicists because they didn't seem to have any. And then it turned around, and now there's a much increased demand for medical physicists. And I think the area medical physics is probably going to continue to expand, and particularly because there's more and more applications for radiation outside of cancer therapy that medical physicists are going to have to get involved in. And there certainly is great opportunities in imaging that medical physicists can make a huge, huge contribution to. So I think that's going to continue, to demand people. Now, in health physics, my sense is that the field has changed since, as you said, since I came into it, and there may not be the same kinds of opportunities for broad exposure to a lot of different pieces of health physics for somebody just coming into the field. I think they're more likely to get slotted into a particular specialty of the field now than we were back in the 1960s. And I think that's kind of too bad, because again, I would get back to my early statement that my advice to anybody coming into a field would be to keep their options open, to learn as much as you can about the various aspects of the field, whether you can get direct experience in it or not. At least learn about it and talk with people that are involved in other parts of the field, and come to meetings like this and go to sessions that talk about something you don't know about, instead of always going to the sessions in the field you're working in. And pick up the course opportunities, and think about where you might be able to apply some different technologies into the area you happen to be working in. Even if you're working in, if you're working in areas like, like site remediation or something, there still may be some dosimetry issues that you need to think about, and you might be able to do some dosimetry work, at least keep your knowledge base up and your understanding of dosimetry. And then if you want to change your orientation, and there's a job open over here at this place that has to do with dosimetry and not remediation, you might have a pretty good chance of getting it if you can demonstrate that you know about dosimetry as well as cleaning up sites. Or same with environmental monitoring or waste handling or whatever. It's just make sure that you don't slot yourself and get so narrow that you can't move if you feel like moving. Now, where health physics is going in the future in terms of people, I'm not a good prognosticator. I think that there's going to be opportunities for health physicists for a long time. I believe that this country is certainly going to have to start building more nuclear power plants. When it's going to happen, I don't know. It may be 20 years before the thing turns around. But there's going to always be applications of radioactive material and radiation sources. And the medical area is one important one. And I think we have to make sure that we've got, well, I think we've got to make sure we've got some training programs. I think that's a big problem right now. We don't have people getting their educations. And I don't have an answer for how we get more training programs going at this point in time. That's not one area I spend a lot of time thinking about. But I think we need them. We need to get more people coming in and more people getting their trained. And we can't forget the area of medical applications in that training. I think that medical health physics is an area where there's going to be a continuing demand for good, well-educated health physicists.
So you're saying diversify.
Diversify.
Keep your options open.
Yeah.
And have the ability, when the field changes, to change with it.
Change with it, yep. That's very important.
Well, this sounds like very
And the way to do that's to get involved.
Yes, absolutely.
And not just sit at your desk every day and focus on what you're getting paid to do, but expand yourself
and be involved in the professional societies.
That's
There
right.
are many of them, actually.
Yes, yeah, right.
Well, Ken, thank you very much for spending this time. The History Committee really appreciates your coming in and sharing this experience. And for me, it's a pleasure to get to know you a little bit better and to understand just how wide and diverse your background is, too. So I thank you very much for this, and you'll be sent the a copy of the tape, and if there's some things you'd like to change in it, we have the masters on beta, so they're very easy to edit. It's not like VCR, that's much more difficult to edit. So we have this set up so that if I said something, you said something that you'd like to have changed, that's awfully easy to do. In fact, if you take a look, this is over now actually. If you take a look at the bottom of the tape, you'll see the time